Hello, everyone. Um, can you give me just a quick shout out on the chat that you can hear me and that if the voice connection is good? Okay, good. Thank you. All right. So today we're going to begin a brand new chapter, and it's about design patterns. We're going to be talking about this chapter for a good 2 weeks or so, and it's one of the most important chapters. I know I keep saying this about every single chapter, but it really is. This and the robustness one is kind of like the two most important things you're gonna get to learn in your software engineering degree, not just this course. Good thing that you did show up today. Let me just change the color here. All right. Now, before I get into the slides itself, I want to talk to you about the subject that we're going to be covering from a general perspective, okay? Now, just to let you know, the way the next few classes are going to be structured, we're going to be talking today about design patterns in general, all right? And then over the next few lectures, we're going to split and start talking about something called creational design patterns, and then structural, and then finally behavioral. All right, and every single lecture I'm going to be asking about, like, oh, so we're doing this, are we doing creational, behavioral, creational, structural, and so on, and it's just going to keep repeating it over and over and over again. By the time we're done with the next 2 weeks, you're going to be sick and tired, you're going to probably memorize them in your sleep. So this is the way it's going to be the next few lectures. Beginning with this lecture, we're going to be talking about just the concept of design patterns in general, which is a prelude for you to get to understand what we're going to be talking about in the next chapters. We're going to be talking about specifically of creational design patterns, structural design patterns, and behavioral design patterns as well. All right. Now, in general, actually, before I get to the slides of the design patterns, in general, this is what lives tend to throw at us, okay? You get to see what we call concrete problems, huh? This is a concrete problem, it's another concrete problem, and another concrete problem, right? And for each one of these problems, we end up creating some sort of solution, concrete solution for this one, and a concrete solution for that one, and a concrete solution for this one as well, all right? And we tend to go through this whole exercise of inventing things from scratch every single time we face one of these problems. Somebody would come and say, well, I'm looking at these problems and I'm actually seeing that there's quite a bit that is in common between those problems. Okay, in other words, a generalized version of the problem, even using the generalized relationship here, as you can see. All right, now the concept here is that this is where design patterns is. If you have a general problem, okay, you see something, for example, I'm renting cars, okay? I'm renting cars, there's a start date, end date, transaction, and so on. Versus, for example, I'm renting hotel rooms, okay? At the end of the day, it's still more or less the same exact thing. And this is why you tend to see a lot of these applications like Expedia and Booking.com end up at the end, um, offering, they start off with flights and then like flights, well, we'll do might as well hotels, because really it's the same thing from a programming perspective, from a technical perspective, okay? From a software perspective, should I say. And then next time they move on to cars, again, because it's the same idea exactly, right? A start date, an end date, a user, and so on and so forth, all right? Really, it's more or less the same exact thing. So when you get to see those concrete problems, you tend to see like there's a flavor for these problems, a generalized version of the flavor for these problems, which you can abstract. It's not an easy thing, okay? It's not an easy thing for somebody who was looking at a website that is booking airlines and look at another website and that is booking car rentals and say, well, are they the same thing? More or less, okay? Another example, like things like hunger station and so on, the delivery. The concept of delivery in general is, I can abstract. It doesn't have to be just food. And actually, somebody was telling me the other day that hunger station now has a feature that you can deliver things other than food. Is that right? I don't actually use hunger station myself, but really, from their perspective, it's like it's good business. Why am I throwing away this business? It's the same exact. I'm connecting two dots together of somebody who is a driver who can deliver some object from point A to point B. Doesn't have to be food. Okay. Program wise, the software is already there. Okay. Then why should I miss out on this market? Okay. Now, the abstraction process is not easy. Okay. But nonetheless, if you were able to do it, you are in a good place that you kind of like figure out the core of this problem, the general sense of this problem. Right. After we've figured out the general problem, we're gonna actually get to figure out a particular solution. Sorry, a general solution, not a particular solution. Okay, and this is what we call a design pattern. Okay, it's a general solution to a general problem. Okay, well, I want to do it for booking airlines, fine. I want to do it for booking hotel rooms, fine. It's the same solution. Okay, all you have to do is change the class from being called car.java to hotelroom.java. Not a big deal. All right, and then those, once you get to the general solution, then you can figure out the concrete specific solution to the problems that we started off with to begin with. Okay, now again, the world gives you this to begin with and gives you that and that only. It is up to you to traverse this whole cycle, to go up, realize what the core problem is, the general problem is, to identify the general solution that I should apply into it, to then apply the specific solution for the specific problem that we all started with to begin with. Okay, this is in general the general concept of design pattern. Matter of fact, we've actually were doing this when we were doing architecture. When we talked about architectural patterns at the beginning of this course, all right, we realized a lot of the things are okay, multiple vendors. The concept of just grasping the idea, oh, this is requiring multiple vendors, or this is going to use 3-tier. Okay, doesn't matter if it was for flights or if it was, for example, jobs. Okay, so a lot of these like monster.com or Gulf, whatever it is, that those job LinkedIn, for example, they go to different vendors and start to retrieve the different job postings from the different institutions, right? But really, technologically, it's exactly the same. Nothing different at all. Okay, but you should have the ingenuity to realize that this is the same thing as that. It's not actually an easy thing to do. All right. So because the cycle actually happens as such, and because the world doesn't come to you and say, this is the concrete problem and this is the general problem of it, that doesn't happen. And for sure it's not gonna, and because it didn't tell you what the general problem is, for sure it's not gonna tell you what the general design pattern is. What I will be doing in this chapter, when I give you questions, all I'm gonna do is I'm gonna give you that. Okay, and it's up to you to complete that cycle, to realize what is the general problem, and then connect it with the general solution to create a specific solution for the specific problem that I've given you. Say what? It's, I'm gonna describing a situation, just like with architecture, but this time it's a little bit more specific. Now, the difference between architecture and what we're doing in design pattern is that architecture was at this level. Okay, and as we're going down to the development, okay, and we're getting closer to code, design patterns tend to fall over here. Okay, so we're talking more about the detail. We're talking about the class level. All right, and design patterns, the solutions we're going to end up with is combinations of classes being set up in a certain way. So it's reuse from this perspective. And if you look at one of the earliest chapters that we had, okay, we said we can do reuse at a method level, like one statement. I can reuse a function, I can reuse a class, or I can reuse a set of classes connected with each other in a certain way to provide a solution for me. Okay, now we're still at we're at this level over here. Okay, because we then what happened is that we jumped and we looked at reuse at a complete architecture level, as saying client server, well, a repository. That's very high level. That's still good. We need to do this. Okay, but it doesn't help us very much when we're talking about the detailed design level. So here we are at the detailed design level. Okay, whereas here at the top, that was the high level design. Okay, or even architecture design. High level design even is a little bit down in the middle. And at the very top over here, this is where we have the requirements. Okay, and so this was the problem domain, and then we entered into the solution domain. All right, before we get to the code at the very bottom. Okay, we've already covered this earlier in the course. Now, in this next few chapters, we're going to be talking about design patterns, and we're going to begin with a prelude chapter for the rest of the other chapters. Okay, so it's 4 chapters, the first of which is just an introduction to design patterns. Okay, 2, 3, and 4, first of which is creational design patterns. All right, and the second one is structural, third one is behavioral. Quite, you were paying attention at the beginning. Okay, now remember when I was telling you that I'm going to use a combination of classes connected to each other to provide a solution? But that solution comes in 3 different flavors. That solution comes in 3 different flavors. One of the problems that I have, okay, is that my issue is with creating objects in a certain way. Okay, then I would go and use one of the creational design patterns. Okay, another problem that I may have, okay, is I want to be able to handle a particular structure, like a linked list or a tree. Very common that we see those structures and that we want to be able to handle them. So I'm going to use a structural design pattern where the structure itself is the problem. Okay. The third of which is behavior design patterns, and these are the ones that I want to have to exhibit a particular type of behavior. Well, I remember one of the behaviors that we kept talking about quite a bit in this course is the state dependent behavior. Okay, like the Super Mario thing or the chess thing that you did in the quiz, and it's a behavior that we want to exhibit. Okay, and in the quiz you draw the state chart diagram, you drew the events and so on. But what about the classes? Okay, state chart diagrams don't actually execute at the end. I don't program state chart diagram. I create classes. Okay, so the design pattern, the state behavior design pattern is the one that by which I'm going to create a whole bunch of classes connected with each other in a certain way to exhibit the state dependent behavior. So now the chess piece that you had in the quiz will start to move around on the chessboard according to the behavior that I wanted, which is state dependent behavior. Okay, or the Super Mario figure that we had in the 2x3 board, it starts to move around in the way that I have, which is a state dependent. Okay, both the chess and Super Mario, both of them are state dependent behaviors. So I can see the common abstract problem to those particular questions, which then I'll be using the state dependent design pattern. So then I'll later on create a specific solution, state-based solution based on my design pattern for one time Super Mario, and another time was for the chess thing. Okay. Speaking of the chess thing, Okay, the events, they're 8. Okay, I'm not sure why there was a lot of trouble in the quiz, but the events, they're 8. The answer is already in the question. All you had to do was just look at the diagram next to it. Okay, it's already showing you the possible events that exist. Okay, event is something, a particular state to state transition is something else. Okay, same event may end up leading to 2 different state transitions. All right, so any questions about what I have on the whiteboard here before I actually begin with the lecture slide itself? Okay, I thought the stuff that I have on the whiteboard tend to help as we begin with the actual slide, so that when you get to see the slide, you say, okay, now I'm fitting this in the whole context of what Dr. El-Attar was telling me about a little earlier on. Okay, actually, let me leave this on. Share. There we go. Guys at home, any questions before I can go back again to the white screen? Any questions at home? No, everything clear? Type. Allah. Oh, there's somebody. Type. So, all good. Okay. So in this next set of slides, we're going to be talking about just giving an introduction to design patterns. And there's a lot of things that are going to be common throughout all the different types of design patterns that we're going to be covering. Okay. We said there's 3 types: creational, behavioral, and structural. Okay. I wanted to, but I guess you were paying attention. That's good. Okay. But still, even within those different design pattern categories, there is still some things that are going to be common. There are going to be things that are common in the way they work, and there are going to be things in common in the way we explain them. Okay. So beginning over here, let's just open this up. So we're going to introduce design patterns, the type, characteristics, and forms. When I have a design pattern, I specify certain information, the first of which is the name of the design pattern. What is the problem that I'm trying to, the abstract problem, followed by the abstract solution. Now, here's one thing I missed to say is the consequences. Okay. When you do something at a design, yes, you're solving a problem, but you got to understand that there's characteristics, there's aspects to your solution. That aspect may have advantages, disadvantages. There's nothing wrong with using a design pattern or any particular design that has a disadvantage that, for example, is not applicable in that particular situation. The key here is that you're aware of it, that you're not oblivious to that consequence that you have. Okay, I'm going to be doing this, this, and that, and you're not aware that this is damaging something else. Okay, you need to know what is the advantage, what is disadvantage. A lot of times you'll realize in this particular situation, the disadvantages don't really count because they're not really applicable. So you're on the right track. Okay. Nonetheless, like I said, the most important part is that you need to be aware of those consequences. All right. So design patterns are class combinations, all right, with some sort of an algorithm to fulfill some sort of a common design purpose. There are descriptions of communicating objects and classes. Customized. So the customized is the part where we go to the specific solution to solve a general problem in a particular context. So a general problem is the abstract problem that we talked about, and particular context is talking about the specific concrete problem that we actually began with. Okay, so a particular context, well, first time it was Super Mario. Second time it was the knight piece in the chess. But both of them belong to the abstract problem of being a state-dependent behavior that I need to exhibit. We have 3 types: creational, structural, and behavioral. I know I just explained, but as we go through the chapters, okay, so the next chapter, was it 9, 10? Okay, it's going to be talking about creational design patterns. We might actually begin this today, I'm not sure. The second chapter following that is structural, and then we end up with the behavior design patterns. Okay, with creational design patterns, we're going to have 3. We're going to look at 3. Structural, look at 4. And behavior design patterns, we'll look at another 4. Okay. There is more. Okay. Design pattern was something that was invented by what we call a gang of four, very famous people in the world of software engineering back in the 90s, and they're still being used until today. And all of the software that you see, okay, is all based on these design patterns being in play. So they're there. Okay. What you might be missing or you're seeing today is the fancy stuff. Okay. The graphical things that are that are pretty cool, pretty amazing, that didn't exist maybe 10, 15 years ago. All right. Is there more? Yes, like I said, there's more. The gang of four, I think their initial set is 17. Now there's more than 100. People in the community have contributed more towards design patterns, and it's one of the biggest contributions that the field of software engineering has provided to the field of IT in general. Okay. Now, with this large collage of design patterns we're going to be covering in this course, it does also offer challenges, because what you're going to get in the exam is a question. It's not going to tell you if it's creational. It's not going to tell you if it's behavioral. It's not going to tell you if it's structural. It's up to you to realize that. And then once you realize, well, this is a behavioral issue, then within the behavior, you got to choose which one of the four to pick from. All right. And it will be some sort of an elimination process. If you remember when we're doing the requirements course, how I asked you and I told you how to differentiate whether it's an include or extend, how they're cousins, and the generalization implementation is another pair of cousins. And I said, well, one way you can do it is just eliminate the general nature of the relationship. So then maybe you can take away one of the two cousins, and then what you're left with is deciding between the last two, okay, whether it's include or extend or generalization or implementation. If you remember from 2 to 5, that's a big if. I hope you still do. All right. When we describe our design patterns, we're going to look at something called viewpoints. It has a static view and a dynamic view. Okay. Obviously, the static view is showing the classes and how they're connected. A lot of times, what I'm going to ask you in the classes in the exam is to show me the static solution. And it's going to show you a dynamic view of how these classes are going to be talking to each other in order to perform a certain functionality as is required by our design problem. Next up, we're going to look at, as we're describing, we're going to look at the different levels. Okay, here's the abstract level, here's the concrete level. Okay, some of the classes that we're going to have are abstract as we use it. Some of the classes that we're going to use are concrete, and they have, whether they're abstract or concrete, they have a role. And this is the third thing that you see on the board over here. Every class has a role to play. Some of these classes are the actual solution to the problem. Some of these classes are the client class. Okay, so they have a client class that is talking to a set of classes to solve a problem. So the client comes in with the problem saying, here, Mr. Or the design pattern group of classes, please take my problem, solve it for me, and come back to me with an answer. Okay, so we have the client, and then sometimes we have some setup code just to set up the actual design pattern itself. Okay, sometimes we set up the design pattern itself. Sometimes we use the setup code to actually, well, create the problem itself. Okay, for example, I want to create a tree. I'm solving a tree problem here, structural design. Well, in order to solve it, I got to create the tree to begin with. All right, I got to create the tree to begin with. So look at it visually. Okay, we said we have the three roles: the client, some setup code maybe at the beginning. Okay, and then we have here the big blue square in the middle. That's the actual design pattern. This is where our class is going to be, and these are the ones that are going to be solving the problems. Now, in that big box, the big blue box, you see there's a static viewpoint of how the classes are connected with each other from a static perspective, using generalization, aggregation, association, and all these sort of things that we've looked at before. And then from a dynamic point of view, all right, using things like sequence diagrams, collaboration diagrams, and so on, and it's showing how these classes are connecting with each other. And mainly, we're going to be looking at really just sequence diagrams. Okay, one type of a interaction diagram. All right. So just to give you a bit of a trailer to one of the design patterns that we're going to look at in this course is the observer design pattern. So the observer design pattern, it has concrete problems at the bottom here. Okay, let me actually put up this slide up. Oh, no, that's not it. Yeah, there we go. Okay, so we got some certain concrete problem, then we identify the problem in general. So we've identified the general problem and the general solution. Finally, with I don't want you paying too much attention on this because it's not really what's going on over here, but nonetheless, this slide over here is trying to explain kind of like what we're going to be seeing. So this is the static view. It's not showing obviously the dynamic view. Over here at the top would be my abstract classes. At the bottom would be my concrete classes. Okay, we might have some sort of a client. Okay, and some maybe initialization code to set up my design pattern and set up my actual, sometimes the problem itself. Okay, observer design pattern is something we're going to come back to when we are doing behavior design pattern. Okay, so we're not explaining it now in this slide, but rather like what you're going to expect to see over the next over the next chapters. Now, every design pattern has an engine, okay? And we have two types of engines, okay? So the engine is the way the design pattern actually works, all right? The actual communication between the different classes and so on, okay? It has an engine form, okay? We have two, the first of which is called delegation, and the second of which is called recursion, okay? And delegation is about delegating responsibility to other classes to do a job for us. Recursion, remember what recursion means from when happens to do what? Calls, yeah, calls itself, exactly, all right? So the classes that we're gonna have in our design patterns, they're going to be calling themselves over and over and over again and repeating a process. This process that is actually repeating is actually delegation. So the second engine, which is called recursion, it actually uses delegation. The only difference is that delegation is a process that happens once. Recursion, it's a process that happens over and over again, where delegations happens over and over and over again. Every single cycle, there's another delegation, another delegation, another delegation, okay? So when we say just delegation, it means a delegation that happened once. Recursion, it means a repetitive process where delegations happen over and over and over and over again until we're done. All right. So a situation, for example, I want to be able to create a particular class in a certain way. Type, okay. It's a one-time shot, one-time process. I'll use delegation for it. Okay. And then we're done. Created the class. Another situation, for example, is handling of a linked list. So every time you say, well, Mr. Object 1, right, perform a certain functionality and then call on the next object, right? It doesn't know how many objects are following. So what you're saying is for every object, call on the next object. And it just keeps repeating and repeating and repeating. And every object does a certain particular functionality and then calls on the next object and the next object and the next object and the next object. Okay. So we have delegation, we have recursion. The engine of recursion contains the engine of delegation. Okay, so the basic idea of delegation is very simple. What we want to do is we don't want the client itself to be dealing with the specific class that does the actual solution. We want to go through some sort of a medium, okay, a delegate. All right. And it basically receives the call and forwards it to the concrete class. Now, the point behind this is, all right, first of all, there is multiple reasons why we want to do this. First of which, we don't want to bother the client with the details of the concrete class. Okay, it's not something that they should know, and frankly, it's something that they don't want to know. Okay, like you walk into a bank, you want to produce a credit card. Okay, you really shouldn't be knowing every single little details, nook and cranny of that bank and how it works, its internal operations, who's working there, how long have they been. It's not really your place to know. You shouldn't be knowing this information. And frankly, you as a customer, you don't really care. Okay, just get me the credit card and thank you very much. All right. Another reason is, had you known all these internal details, then it opens up room for abuse. Okay, and this is what actually happens in the real world. The third reason, I'm trying to remember what the third reason was, just in my mind a moment ago. The third reason is that when you depend on the concrete classes by nature are more volatile. Volatile, I mean, they tend to change more, whereas the more abstract classes tend to be more stable. Okay, so if you take, say, a hierarchy of vehicles, okay, at the very top, the most abstract class is the vehicle. The very bottom, we have a very, very concrete class of a Toyota Camry 2020 blue GLE with blah blah blah. So this color and so on, and interior and exterior and so on. Okay, very, very specific class. One thing you can know for sure: this class is only going to be valid for 1 year. Next year, something else is going to happen. Okay, so as a client, if you want to depend on that, you're depending on something that's very volatile. Okay, now if I have a variable in my client of the class type of the very concrete class, it's not going to be long before I have to go back and update the client. And it's very bothersome for the client that I have to go and fill around in its code when the change is happening somewhere else. However, on the other side, on the other hand, if you look at the general concept of a vehicle, that's unlikely to change anytime soon. Okay, something with 4 wheels and an engine. That's it. All right. So if you depend on that, it's going to be a long time before, and I have a class, a variable of type vehicle in my client class. It's very unlikely anytime soon that I'm going to be changing my client code because class vehicle has changed and we're using something else, vehicle X, for example. It's not going to happen. Not now, not 100 years from now. All right, so this is delegation. All good? All right. Next up, no, we're still actually here. All right, so we have the client, and basically the client comes in, and instead of talking to let me actually use this on here, it's better, so that people at home can see too. So here's my client, and instead of talking to the concrete classes at the bottom immediately, and we're kind of like leaving the customer up into this world of details that they don't really care about and they shouldn't know about, and so on and so forth. We have a representative, an interface, the design pattern interface that says, stop here, let me help you. How can I help you? What are you looking for? Are you looking for this? Okay, please have a seat. We'll get it done for you. And then the interface then tells the design pattern, this is, you can think about it, this is the actual design pattern work. The interface gives the job to that design pattern and says, well, my client is asking for this, this, and that. They do the job. This guy over here, the abstract, knows its employees, so to speak, and they know the details. Meanwhile, Mr. Customer, Mr. Client is sitting in the waiting room, sipping coffee, and just indulging himself, not really caring about the details until the job is done. Okay? Now, delegation, which, as we said, is used in the recursion engine as well, it is mainly dependent on the concept of polymorphism. Okay. Now, polymorphism is one of the trickiest subjects that you come across when you're doing 120 or maybe even 220 as well. Okay. So we'll cover it again, but from a design perspective. Okay. Now, assuming you have this setup over here, we have a client, all right, and is calling upon some sort of a target state. So it has a variable of type target state in its code, as you see over here. All right. And one of the concrete targets is the on class. Okay. So it's one of the states. The concrete state is the on class. Okay. Type. So the client here, this variable target state, what really happens and how polymorphism actually works is that you have an object and it has an envelope. Okay. The envelope from the outside has a name, but what's inside is something else. Okay. So the envelope from the outside says target state, this one over here. But what's really inside is an object of type on. Okay. From the perspective of the client, it looks like all I have is an object of type target state. Okay. And what we can use this for is that every time we can flip what's inside dynamically, assign and bind any type of class inside that envelope, while from the perspective of client, we can play stupid and say, oh, all the while I thought I was dealing with target state. That leaves us with a lot of flexibility. That leaves us with a lot of stability because client is going to be just looking at target state, which is not going to be changing anytime soon, just like the class vehicle. Whereas, wallah, this year it was Toyota Camry 2020 blue. Next year, Toyota Camry 2021 blue. So take out the Toyota Camry that was in the middle and put inside another one, and we're good. We're back in business. All right. So we have an on class. Now what happens is that target state has a function called turn off, which is obviously implemented because this one's an abstract. It's implemented or at least inherited by the concrete class called on. Okay. What happens that when the client executes a turn off command, okay, heads up, please, phones down. The one part of the class that I want you to. Okay. So from its perspective, it thinks it's sending the target class or the target object that it owns a turn off command. Okay. Turn off command wants to do the job, but it realizes it's abstract and that it's hollow from inside. So it looks inside and realizes, well, I got nothing. Right now, I'm gonna delegate this job to what's inside the envelope. What's inside the envelope is a class called on that obviously inherits turn off. Okay. And so what actually executes is not the code that was here. What actually executes is the code that's at the bottom over there. Okay. This, in a nutshell, is polymorphism. I hope this was matching what you had in your mind back when you actually took polymorphism in your object-oriented class. Okay. This is used quite heavily in design patterns. Okay. And maybe when you were taking polymorphism back in 120, it's like, what the heck is this useful for? And why am I taking this? It's really, really useful when it comes to design patterns. Okay. All right. The second engine, now that we understand delegation and we understand polymorphism, okay, it actually looks very similar to the delegation. So a call comes in here to something that is abstract. Okay, it delegates it to one of the bottom classes. But then one of the bottom classes, after it does its job, it forwards the call to another object of its own type to continue working on the job. Right? This self-association is something you actually were exposed to in the quiz. Okay, remember that the question about the directories, electronic files, and all that. So really, we had electronic files that had inside of them files, and this is the end leaves. And then we had directory. Yes, good job. Directory. And then directory would point back again to, okay, so assuming you said at the root directory, expand all the things inside. First of all, the person who's the client who's looking at the root directory doesn't know what's inside. And it doesn't make sense to let them know what's inside. Okay, it's just saying root directory, open up what's inside of you. I don't really know what's inside of you, but go ahead and open it. Okay, so it starts to open. Okay, now you hit another directory. What you want to do is you want to be reusing recursion so that you get the inside directory to re-execute the same code itself and pass on the functionality to the next in line and repeat itself and repeat. And we're using recursion because we don't actually know how many are coming up. Do I have 3 directories? Do I have 15? And what's inside those 15? How many files are in there? We don't know. We don't know. It's dynamic. Okay. Another good reason why we want to be using recursion is that other than just not letting the client needing to know that we have 4 directories and the first directory has this number of directories and this number of files and so on. What if after I click on and I start, I change the files and I change the directories? Do I have to like stop the code and run it again? That doesn't make sense. Okay, we want it to be dynamic. We want it to be, so khalas, we change one of the directories, it then is able to handle the new structure that we get. Hint, structural design pattern here again. Okay. Nonetheless, we still haven't started off with the structural design patterns. Okay. But the objects inside the structure or the objects inside a set of classes that are handling a particular job start to talk to each other in a recursive manner in order to get the job to be done. Whether it's a structure of similar objects, for example, 15 students, and I just want to print the GPA of every student. Okay, so it's a linked list of objects, all of which are the same type, and all of which are I want to perform something on them, or maybe a linked list of objects. Each one of them is actually doing a part of the job. Okay, kind of like in a restaurant. Somebody does the fries, and then you move on to the next person in line. Somebody does the chicken, and then moves on to the next person in line. Somebody does the pasta, right, and so on and so forth. Where everybody has a job to do. Okay, but basically it's like a factory line. Somebody does something, moves on to the next person, and says, "Okay, now your turn. You go ahead. You do your part." All right. Still, nonetheless, it still uses polymorphism. Class client in its code, it thinks it has an object of type recursive base, which is this one over here. Okay, but really recursive base at any point is going to either have a non-recursive class, an object of non-recursive class, or recursive class. Okay, so if we reach the non-recursive class, something's going to execute that actually belongs to this code over here, and then we stop because we're at the leaf end. Okay, if we used an object of recursive path, okay, we execute the code over here. And then we actually remove the object and we go back up over here and we say next object in line. That next object in line could have been a non-recursive one, or it could have been a recursive one. But nonetheless, all the while, the client thinks it's just dealing with recursive base object all the while. Okay. Now, let me stop here for a second. It's too loud. Make sure I switch this. All right. Okay. So let's assume we have that structure, huh? Okay, a tree structure. Okay. So I have a directory. Okay. Just like the quiz question. And then inside it had another directory. And then inside it had another directory. And there's another file. And here we have a file and another file, another directory, and a file. Okay. This is where it all begins. The client comes in. The client comes in, says, picks up the first one, the root directory, and says, well, okay, expand everything that you have inside. Just kind of like what you see in your file explorer. Okay. So the client, okay, it thinks it's dealing with an object of type electronic file. Okay. Electronic file, that relationship between it and the client actually never changes. Okay. Everything over here is of type I picked the wrong worst place. Here we go. Electronic file, right? So first one is we pick up the first directory, and it's actually this one in here. And we put it over there, and we execute expand. Which expand are we actually executing? This one over there. Okay. And then it says go on by recursion. Okay. So here we are. Let me just draw this over here. So those electronic files. We had a file and a directory. And then it says, go on, move on to the next one. Now, it actually doesn't know what the next one type is. Okay, it knows it's gonna be an electronic file, but it doesn't know exactly which type. So it just says move. And this is why you see the aggregation is not pointing to file directly, because if it was, then for sure every directory is gonna have just one file. And that's it. Okay. Now, it executes. We executed this over there. طيب, next up, we remove that. Okay. We move on to the next. The next one in line. The next one in line would be this directory over here. So actually, we're removing this one. So this was this one over there. We're removing it. And now we're going to put that one over here. So although from the inside, it's still a directory object, but it's actually a different type of directory object. So this was, say, beginning D1. I could have just used that at the beginning. And this was D2. We actually moved D1 and we put inside D2. And then when we're done with D2, we're going to remove it and put down D3. And when we're done with D3, all the while, the client thinks it's holding on to one object. And it's called electronic file. And inside, a lot of things are flipping. And in the end, it's going to be dealing with an object of type file. And that will be the end of my recursion. Okay. Not necessarily the end, because after we're done with the first file, we go back up and then we go down again. And then we go back up and then we go down, because it's tree structure. Okay. Had it been a LinkedIn, a linked list. All right, where this was, this is the leaf node, this is non-leaf, non-leaf. Okay, it's still the same thing over here. Okay, except for this one is going to call, this one is going to call. But once we hit the last one, it knows the last one is this one over here. It knows we're not going anywhere else, and the recursion stops. All right. Am I still holding on to you or did I lose you? Everybody at home so far, do you understand? Do you understand what I'm talking about? Can I see some text just to make sure that I didn't lose you? Okay, طب كويس. Good, good, good. All right. Here's, for example, an organizational structure of employees that can be a supervisor, otherwise it's supervising other employees, and there's some individual contributors, i.e. the persons who are not supervising others. So if I want to print out, say, all the names of my organization, then I'll go through the tree in the same exact way I did through the directory list. All right. Had enough or next chapter? Let me just pause this for a second. Home, huh? Mm. All right, so a new chapter it is based on popular demand. I always thought we got 20 minutes. We can do something. Type. So just give you a flavor here. So the first of the three types, creational design patterns. The second one is structural. The last one is behavioral design pattern. Okay, wake up, wake up. Okay, so in creational design pattern, we're going to look at three different design patterns. The first of which is factory, followed by abstract, followed by singleton. We'll cover factory today. So the next one is actually pretty complicated. So now the whole point behind the factory design pattern is we're trying to create individual objects in situations where the client class need not to know all the details of the constructs. Okay, so we're going to use methods to return the objects for us. Very, very simple design pattern. Okay, we have a class in the middle. Instead of getting the client to create the classes themselves, okay, we're gonna go through some sort of a delegate, and we go up here and ask the client, the design pattern interface to create the required object for us. Okay. All right. So the sequence diagram is very simple. Okay, we don't have it connecting directly. We have an intermediate in the middle, and all right, the whole point behind this design pattern, okay, as you can see, so you got the client asking the automobile class to create, say, an object of type Ford, an object of type Toyota. That's fine, but really the purpose of the factory design pattern is to shield away details when you are asking for an object to be created. You know what you want, but you don't have all the details. Like, if you open up on your phone, since you're using your phones quite a bit, okay, there's a new iPhone that came out, like iPhone. Open the one you want, any one you want. Okay, did you buy it already? Okay. Did I not sharing the class? 12. Okay, so Mariam, 12. Was it 12 Pro or a 12? See, now I'm already bothering you. 12. 12 Pro or a 12, the regular one? Well, the big screen, small screen. Okay. Nonetheless, Mariam, are you still here? So what I want you to do is just Google iPhone. Yeah, iPhone 12 specifications. Okay. Regular. Okay. So here it is, iPhone 12 specifications. Click on the first link that you get. All right. Says hello to 5G and so on. Even them, they're trying to shield away. That's a video. Should have actually, oh, there we go. There we go. Right. So, assuming, Mariam, that you wanted the iPhone 12 Pro Max, and the reason I'm asking this is because it's the one that I have in front of you on the screen. Okay, imagine you go into, I don't know, Jarir, Extra, or what is it is that you're trying to buy that phone, and what, as a client or as a customer, do you expect your experience to be like when you're asking for the iPhone 12 Pro Max? You're gonna say, "Excuse me, sir or miss, I would like to buy." What are you gonna say, Mariam?
I would like to buy the iPhone.
iPhone, yeah. And then the person comes back and says, "iPhone what?
Okay, iPhone 12 Pro
iPhone 12 Pro what?" And if he Max,
Max.
عادي. Okay. See,
Max.
and that's probably enough. That's probably enough. Okay. Um, that's usually enough detail for the person who's working there to understand what you want. Now, did you give that person all the information that they need? Not necessarily. Okay. There's still a lot of details about the phone that you've missed out. When a class execute a constructor, it has to provide all the parameters for that constructor to create that class. Okay, for a student class, you give them the name, the ID, the GPA, and so on and so forth. Type. If you're doing the same thing in the world of software, you got to give all the parameters of that phone. You can't just say iPhone 12 Pro Max. Okay, so Mariam, I'm going to ask you, what is the screen size?
For the 12,
What?
6.1.
No, 6.7. That's the max. Okay.
Oh, okay.
How many RAMs?
Uh,
Allah, Swara, are you Googling it? You're not supposed to be Googling it. How many RAMs?
I'm Googling.
Don't Google it. Don't Google it. That was already annoying. Okay. Okay.
Yeah.
So you Google it while you're standing at Extra, and you tell the person 6 gig RAMs, and then the other person comes back and says, how many milliamperes is the battery? You need to say 3,687. Come on. At this point, you're really, really annoyed. Okay. You're gonna say, "Well, I gotta خلصنا بقى. We want the iPhone Pro Max يعني خلصنا." Right? This is probably the experience that you're going through. I give you enough information. Just give me the thing, right? At most, I'm going to tell you the color, and that's probably it. What am I? What are you laughing at? Yeah, pretty cool. Yeah. Like, that's really the point behind the factory design plan, is that we're going to get from the customer just enough. And we say, well, I don't want you to give us all the details. We're going to figure out the details. I'm going to plug in the details myself. This is my job. All right. It's not really your job as the customer to know all these. I need to know from you just enough. Okay. Like, for example, the other day when I lost my charger, okay, I went to Garir to buy another charger, and the person asked me, well, is it Surface Pro or regular Surface? Because that actually makes a difference in selling me the wrong charger or not. Okay. But beyond this, if you flip the charger, there's millions of little pieces of small information that exist. And if I'm going to have to answer each one of those questions, I'm just going to end up leaving. All right. Okay. So here we are. Why is this not working? All right. So assuming I have an application that models the assembly of a variety of personal computers. The application contains a computer assembler class that is responsible for creating the specific computers, a computer class that models the computer being built, a computer factory that creates the instances of the computer. In using the factory design pattern, the assembler class can delegate the responsibility of creation. So the assembler is the client, assembly, the computer factory is the intermediate in the middle, who's going to be playing the role of the delegate. And then finally, the computers are the actual products that we're creating. Okay. So here I have an abstract class called computer. Okay. Follow me on this logic. Okay. So I got computer, and I have two things in it. It talks about a gigahertz and some sort of a memory. Okay. And all computers fall onto, they have to have a gigahertz and a memory. Okay. Now I have a specific type of computers called new computer with certain gigahertz, RAM, and so on. These are the details, sakhifa, okay, that the client really doesn't want to bother with. Okay, so we got new client, sorry, new computer, and then we got also, as we'll see in a moment, old computer. Okay, so old computers got slower gigahertz, RAM, and a smaller memory. Okay, and that's another concrete computer. Okay, now the factory that's in the middle. Okay, all it does, all right, it receives from the client. Just tell me the name. You want new or you want old? If you tell me new, I'm gonna go ahead and return a new computer. Otherwise, I'm gonna return an object of type old computer. Very, very simple. Okay, so the factory, computer factory, and the factory, oops, gets requests from the client, and all it's asking is that you tell me, am I getting new or am I getting old? And I'll figure out the details myself. Okay. So here is the client, which is the computer assembler. Okay. It has obviously a connection to a computer factory class. Okay. So that's you talking to the person who's working at Extra. All right. You ask for, you ask the factory object to get me a new computer, and what you're asking for is new. Okay. So remember the factory object, it takes in the function get computer a string. Okay. So I'm going to use the get computer function, and I'm going to give it the string new. All right. And then I'm going to execute get computer speed just to return the speed. It's going to print out obviously the speed of the new computer. But basically, before we even get to the last one, what has been returned over here from the perspective of the client is an object of type computer. Okay. But what's inside is an object of type those of you at home, new computer. Yes, very good. And so when you execute, we got 1 minute. Okay. So when we execute get computer speed, we're actually executing get computer speed, which will then deal with the object that's inside. Okay. So it then gets, where is it? It gets this speed over here, one of, I think, 2.3. Okay. The other one, same deal. It just gets an object of old computer. And when we actually do the printouts, it prints out the relative information. Now, the speed, the gigahertz, the RAM, from the perspective of the client, look at the client over here, huh? Look at the client. Do you see a specification for gigahertz, RAM, or speed? Nothing, okay? All they have to say is new or old. That's it, okay? And also, a good thing is that I'm dealing with all my life with the concept of a computer. Well, a new computer, new computer, new, triple new computer. That's not really my business. Okay. So it's flexible in that regard, and that I don't have to keep updating and updating and updating over and over again. All right. So that's it, guys at home. Do you have any questions? Guys at home, any questions about this? Okay. All right, so that's it for today. I'll see you inshallah on Wednesday.